Hi, grade 12s. I want us to look at sketching a cubic function and the steps that you need to take to sketch a graph. Sketching a cubic function. Right. When you sketch a cubic functions, there are a few things that you need. Just gonna list them down so that you know what is it that you would have to use to sketch the graph. But I would advise you to always list all three things or more than three. What you need, number one, we need stationary points. Um, that's that's the first thing that you would determine, like I mentioned in a class. Number two, you would need x-intercepts. Number three, you would need y-intercept. So if you use these three things, you will be able to draw the accurate graph. So your graph can either have one x-intercept or more than one x-intercept. So the highest number of x-intercept that this function or a cubic function can have is going to be two. Your stationary points, you must remember that we find stationary points by deriving the equation, and when we derive the function, the derivative for stationary points must equal to zero, so that you can find two x-intercept or two x coordinates of a stationary points, and then you use those x coordinates to determine your y or their y coordinates. All right. So let's take example using this equation. Let's say you are given f of x equals to 2x cubed minus 3x squared minus 12x. And yeah, this is the equation. And we need to sketch the graph of this function here. Let's start with the first step. We need to find the stationary points. So all you're going to do is to write for stationary points. We know that the derivative has to equal to zero. Then we have to derive this. The derivative of this function is going to be 6x squared minus 6x and then minus 12. Remember, we just said that this must equal to zero. So therefore, 6x squared minus 6x minus 12 must equal to zero. Then from here, we can divide everything by 6 because it is our common value. And we then get an equation of x squared minus x minus 2 equals to 0. From here, we need to factorize this equation to get two coordinates of x. So when we factorize this, we then get x minus 2 and x plus 1. From here, we know the coordinates will then be x equals to 2 or x equals to -1. So we have just determined the x coordinates of our stationary points. So from here, we just need the y coordinates. What we're then going to do, we're going to take this x coordinates and then subs them into subs this into the equation, subs into f of x. So what we are then going to work out will be f of 2 will give us 2 into 2 cubed minus 3 into 2 squared minus 12 times 2, which we then get, this is 824 minus, this is 412, this is another 24. The answer that I get here, yeah, it's 8 times, so I made a mistake there. It's not 24, that's 16, not 24. So it's 8 times 2, which is 16. This is 4 times 3, which is 12, and 12 times 2, which will give us 24. Right, so from here, the answer that I get is 16 minus 12 is 4. 4 minus 24 is minus 20. Right. So the coordinates that we have for our station at the first stationary point, we'll have the coordinates 2 and negative 20. Then we need to find the second station point of stationary point. We substitute -1. So we'll do f of -1, which will give us 2 into -1 cubed minus 3 into -1 squared minus 12 into -1. But you don't have to show all of the steps. You can just punch this into your calculator and get your answer. Your substitution is the one that is important. So here we get -1, which is -2. Here we're going to get +1, which will give us -3. Negative times negative, we get +12. So if we take +12, subtract 5, we get +7. So the coordinates here are going to be -1 and +7. All right. So we now have our stationary point. So if you look at this point, it is going to be a point that faces up. So this one is going to be our minimal stationary points. However, if you look at this one, we go to -1. Yes, so we go to -1. That one is going to give us our maximum stationary points. So how would you know that a stationary point is minimum? If for some odd reason, your y coordinate is the least or is a negative. So not always the negative, but if it is the lowest, the one that has the lowest y coordinate is the one that will have a minimum, and the one that has the highest y coordinate will be the maximum. That's how you actually determine it, or to know. All right, so from here we know that this is where this function is going to make a turn. Now, let's go to point number 2. So for point number 2, we need x-intercepts. So to determine x-intercepts, we are going to have to use either the synthetic theorem. So we do number 2 now. X-intercepts. We remember our x-intercepts, and f of x must equal to 0. So if we look at this equation, we're going to get 0 equals to 2x cubed minus 3 into x squared minus 12x And it's easy to factorize this one because we have our highest common factor of x everywhere. So we can take out x, and then what we have here, we are going to get 2x squared, and then minus 3x minus 12. We just need to factorize this part and get um, the other factors where possible. So what I see here is that if we're looking for the factors of 24, when you subtract them, you get 3. 6 times 4, 12 times 2, 8 times 3. So unfortunately, we cannot factorize this. We are going to get a decimal number, right? So I would then ask, when you get to this part, you then have to use a calculator. So we are going to use that complete squares, a quadratic equation. For a quadratic equation. So that would be option 5. We are looking for x squared, option 2. A equals to 2, B equals to negative 3, and C equals to negative 12. Okay. The coordinates that I have are, so we have x into, we can leave this as it is. So what we are then going to do from here, we can say, since it's not easy to factorize this, we would have to use the quadratic equation to solve this one. The first x coordinate is going to be x equals to 0, or we're going to then take this whole equation of 2x squared minus 3x minus 12 equals to 0. And then we use the quadratic equation here. Remember, your quadratic equation is written this way: minus b plus or minus the square root of b squared minus 4ac all over 2a. So this is the equation that we are going to use to find the other two factors. Right, what I get here was, I'm going back to my calculator, get 3.3. No, this is not moving. Right, I get 3.3 as one of my x coordinate, 3.3, and or the other one is going to be x equals to, it has to be a negative number. Let's see, the second one is negative 1.8. Negative 1.8. So those are the 3x coordinate or x intercepts that I found. So let's write all of them. So the first one is going to be x equals to 0 and y has to be 0. Because if we substitute the 0 in this equation here, you don't have to substitute it because we know that we're working out the x-intercept. So y has to be 0. So we look at the second one. X is 3.3 and y has to be 0. 3.3 and 0. And the third one is x is negative 1.8 and then y has to be 0. So those are the 3 x-intercepts that we actually determine. Technically, if you look at this one, at this point here, it's already our y-intercept because x is 0 here, and you get the y coordinate as 0. The other way that you can look at it is that if you go back to your main equation, you can see we do not have a constant. So that if you remember in any standard equation, your constant is actually your y-intercept. So our y-intercept here is equal to 0. So you could have actually just added a 0 there if you wanted to. All right. So we have determined three things that we need to draw our graph. Right. So let us go to the next page. I'll try and see. Today I'm going to try and draw as accurate a graph that's accurate as far as I can. I'm going to use a grid thing here. All right. So I need my Cartesian plane so that I can draw the function. Take this one. I'll also show you on using GeoGebra how your graph would look like. But I wanted to actually draw it with you guys so that you can all see. I'm trying to make it as large as possible. All right, so I think this will be big enough. All right, so let's go back. We know that our stationary points, let's start with stationary points. I've got -1 and 7. That one is easy to draw. So here's our -1, and we count up to 7. So this part here, x is -1. So here's our -1 and 7. I would count maybe in threes. The reason why I'm going to count my y values in threes is because of the fact that I have another stationary point, which is about -20. Well, maybe let me count in two so that I can get -20. So I will go 2, 4, 6, 8, 10, 12, 14, 16, 18. So 20 is somewhere there. So even going down, we're going to have 20, that is just after. So you have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 is here. So -20 is somewhere down there. I'll just extend it. So, all right. So we do our stationary points. We said this function has to turn at -1 and 7. So 2, 4, 6, 7 is in between. So I'll put a point there. So we know that this is going to be, it's going to make it 10 facing down. And then the other one, it was 2 and -20. So it's 2 and -20. So here is 2. And here is our -20. And this graph will make it 10 here. What we said we need is that this graph would have to go through x-intercept or through 0 and 0 first, so which is going to be here. This is a point of 0 and 0. And it will also go through points, let me just look at that, -1.8. It's going to go through point -1.8 and 3.3. So -1.8, we can put it somewhere around here. And -3.3, so this is 4. And here, 1, 2, 3, 4 is here. And 3.3 could be somewhere there. That looks more like 3.5. So those are the 3 points that that we need in terms of our x-intercept. This is 0 and 0. This is 0, 3.3 and 0. 3.3 and 0. And this point here is negative 1.8 and 0. So we need this 3 points to show where our graph is going to cut through the x coordinates and the y-intercept. So when we draw this graph, it's going to turn like this. So I should have made it do a nice curve there. So it's going to turn here. It's going to go through that point, and it will then go through this one as well. 0 and 0. And we're going like this. And then this will go up. And we know it's going to cut through this point. Like a 10 there. And basically, this is your function. It would look like this. So this is how you draw a cubic function. So let us then look at GeoGebra. I'll just show you quickly with GeoGebra how this function would look like. You guys are not allowed to use GeoGebra, unfortunately. I'll do it with GeoGebra just to show you that that's going to be an accurate function. Let me open my graph. All right, let's go back. Where is all right, so let me share a different screen with you guys because I need you to see it through GeoGebra. All right, where is my right? I need points where this graph starts. Where's my 0 mark? There we go. And I was looking for this. Right, so let's enter the equation so that you guys can see. We said f of x will then equal to f of x equals to, let me take an equation. It is 2x cubed. 2x cubed minus 3x squared. And then I have minus 12x. Right, enter. So this is the function. This is how it looks like, just like what I did. You can see it makes a 10 here at 7, and I count it in twos as well. So it makes a 10 here at 7, and then it makes a 10 here at minus 20, just like what I showed you guys. And then it goes through that point of 0 and 0. This is negative 1.8. And this is going to be around about 3.3. All right. So this is, in a nutshell, how this function is drawn. When you sketch a graph, Those are the key important parts that you need. You need two stationary points. You need the x-intercepts just to know where that function is going to make a turn. All right, I hope this helps and you guys get an understanding of how to sketch the graph. All right. Next, what we are then going to look at is in the next video, we are then going to look at concavity, like how I explained to you guys in a class, looking at the point of inflection and also determining when does the graph concave up or concave down. So in a nutshell, we know our point of inflection will be somewhere here. When we are saying if a function concaves up, it means from this section here, you can see below here, this graph is going to make a curve that goes up. So this is concave up. So the function will concave up at a minimum turning point or at a minimum stationary point, and then it will concave down. So it's going to concave down at a maximum turning point. So I just wanted to clear that so that you understand what concavity means. So in this case, it's going to concave down on this section and it's going to concave up on this section. All right. If there are any queries, please feel free to approach me during class. Oh, sorry, I think you did not see my screen when I referred to concavity. Right, let me explain that again to you guys. I said the function will concave up if it has a minimum turning point, and it will concave down when it has a maximum turning point. So what do I mean by that? On the video, I said to you here, if this is our point of inflection, so this graph here, it is going to concave up here. So it will go down and then it concaves up. And then here, on the other hand, it will go up and then it concaves down. So this section, that's where it makes a concave, and this section as well, that's where it makes a concave. So this concave is facing up, and then this part of the concave is facing down. So this is a concave down, and this is going to be a concave up. Right. I hope this is clearer in terms of concavity, and then we will look into how to determine this concavity. When does it make a concave up or when does it make a concave down? All right, guys, this is it for today. We will then do a follow-up video covering these concepts. Thank you. Bye.